energy building and plus zero energy vehicle. And the first part, as you can see in the diagram below, the configuration of the system, the right line representing the flow direction of electricity generated, and the blue line representing the flow of stored energy, and the plus number refers to the charging priority. The minus plus number refers to the discharging priority, and electricity is generated by the offshore PV panel and offshore wind turbine, which together provide basic electric demand of building and EV battery. Then when we have surplus energy, we will, according the priority, store them into battery, or convert it into thermal energy into the water storage tank or cooling storage tank. Oh, by the way, in the there are two EV battery, but actually I only design one EV battery. The basic one is it may not full charge, and the EV battery in this area representing the margin between the full charge with the basic line. And the components of my developed system is mainly divided into three parts. First is the electrical generation device, offshore PV panel and offshore wind turbine. The second part is thermal energy storage system. We have AHU cooling storage tank and domestic hot water tank. Then the electrical energy storage system with EV battery and static battery. My control strategy and control logic is based on the following 3 points. First is the electric generation. We'll try to cover the basic electric demand of building an EV. Then when the electrical generation more than the basic electric demand, there have two ways to store them. First is to supply. First is domestic. The supplies will try to charge the battery or convert it into thermal energy. Then, if there still have a surplus, it can be exported to the electric grid. When the electrical generation can cover the basic electrical demand, we also have two ways to support it. First is use the electric stored from the domestic. The shortage will first try to be covered by the stored thermal energy and discharging the battery. Or if there's still a shortage, it can be supplied from the electric grid. And then is the detailed priority of charging and duration. First, I will give the first priority, of course, excluding the basic demand. I will give the first priority to the EV battery at here, because I think it's more flexible and electric energy. I think it can keep a high quality of energy, because since the electric energy can be used as electrical directly or converted into heat energy, into thermal energy in the system. But you can see here the cooling storage tank or the water storage tank, they are all thermal energy. It can't be converted into electric in this system. And I give the second priority to the I give the second priority to the recharging chiller, because my building is also located in Hong Kong, and I think the demand and the importance of the cooling in Hong Kong is more significant than the hot water system. Then I give the third priority to the hot water storage tank, to recharging the electric heater. It's not that important, but it's high frequency. It has a high frequency to use, and then is the static battery. It's not a then is a static battery. Is the energy is still stored in the building, and the last choice is to export the electric into the grid. In this way, we can balance the electricity use from the grid when the electrical generation is insufficient. And for the discharging priority, I will first use the electricity from static battery, because it's only used to store electricity energy and don't have another function, so it won't have effect on other components. Then I will use the EV battery, because it's still within the building. It's still domestic. When the last choice is the electric grid. It can meet all the shortage. And this is the established this is my system established in transit environment. You can see I haven't completed. I just put some general arrangement, but detailed setting and the components and connect I haven't finished yet.
Okay, so I think for the this sentence is wrong.
Oh.
Okay. So, but anyway, so this progress, I would say, for the design of the system, that's satisfied. That's satisfied. For the design of the system, I can see that you have proposed a very detailed design for the system, for the this thermal system, and as well as for the electricity system. Our design is quite logical. But for the progress in this transit simulation, I would say that's something still missing. At the same time, have you sized your demand? So do you know what is the demand?
I just assume my building is one building, 2 floors, but I haven't built the building into the transit.
Okay, so I can see that for the progress, design is quite good, but for sizing of the system, so what is the exact demand profile for your building? and also what is the exact profile for your vehicle, it is still unknown. And also duration curves, of course, is still there is no duration curve, so we have to check the duration curves. Then you can go on to size the generator, including the thermal system and also the electricity system. Otherwise, you cannot go on. I would say. And for the TwinSys simulation, I can see that in your system currently it is still the electricity system, nothing else. So you have to speed up. Otherwise, I'm just a bit worried about so what kind of initial results can you show in the midterm assessment. So in the midterm assessment, not only for you, for all the students here, you need to show some initial results. So it means what? It means that you have to establish the system actually before the midterm assessment, before the beginning of December. So you have around I think a couple of weeks time to refine the system, to set up the connections in TwinSys for both the thermal system and also electricity system. So this is something you need to do, and you need to speed up for the system side for the TwinSys simulation. Okay, but anyway, I think your topic is somehow similar as I think zero entry building and zero entry vehicle, so similar as Chen Xing's topic. So if there is anything, for example, both of you are confused, you can also have a chat and discuss together. So for these systems, but for Chen Xing, I think you are using, for example, the solar energy and also the wind energy, but for shooting you are using ocean energy. But it's just the only differences between the generator side for the building, zero entry building and zero entry vehicle. The controls, I would say, they are somehow similar between each other. Of course, for the shooting, you are doing a master project, so that will be a bit more complicated. For example, you are already integrating the thermal system into the design. Okay. Yes. But anyway, is there any question from you, Chen Xing, for shooting's design? Yeah. If you have any question, you can also suggest. Around the regarding control, or is there anything not clear?
It's fine.
Okay. But anyway, so during the simulation process, of course, you can have a chat to see probably there are some common controls, so you can have a discussion. Okay. So next student, let's see, Sian Kit. I think you're working on solar energy. Are you there?
Yes.
Yeah. Yan Kit, did you send me email?
No.
It's not you.
Yeah.
Okay, I remember 2 students sent me email, but it seems 9 students here. Okay, so this I think you can show your screen, share your screen with us.